Chapter 3.6 is the fundamental theorem of algebra. This is kind of a beefy lesson. There's a lot to it, so be ready. Notice I have a picture of some eyes. There's two of them. There's a pair of eyes. Eyes usually come in twos. Just remember that, okay? All right, so this first bit on your notes shows a little table. We have an equation here, and the degree, remember that the degree of an equation is the highest exponent in the equation, okay? And so in this one, we have just an x. So the highest degree is 1, all right? So that's my degree. And if I solved for x, I would get 1/2. So the number of solutions is just 1. All right. My degree here is 2. That's my highest exponent. So the degree is 2. If I solve it, I get a positive and a negative. That is 2 solutions. Here, my highest exponent is 3, so it's of degree 3. I have 3 solutions. I know that 2 of them are the same thing, but I still have 3 solutions. And this is basically, very basically, the fundamental theorem of algebra. So if you take a minute and you look at this, you'll notice that this column and this column are the same. So the degree of your polynomial is how many solutions you're going to have. Which is, this is also in your notes. One thing that I do want to point out here though, and I kind of said it already, that each solution repeated twice is counted as 2 solutions. So that one was -1 and -1 and 1. Those negative ones count twice because we had them twice. All right, and if there are 3 that repeat, all 3 of them count. All right, so in other words, like I said, the degree of your polynomial is the number of roots that you have. Well, the kind of roots you have, well, they're not all going to be the same kind. All right, so let's talk about this for just a minute. So what we have here is a quadratic function. We know that from the beginning of the year. And a quadratic function looks like, well, is a parabola, right? It's a U shape, either up or down. This one's up because it's positive. And based on what we know with transformations, the +5 means that it's up 5, so it's going to open up, and the vertex is going to be up 5. So 1, 2, 3, 4, 5 goes like this. Well, I taught you before that roots cross the x-axis, right? Yeah. So this one doesn't have any roots. Yeah, but didn't I just tell you that the number of roots is your degree of your polynomial? Yeah. So am I lying to you? Well, no. This polynomial just doesn't have any real roots. It's real roots that cross the x-axis. So let's solve for x, and I'll show you what kind of roots this polynomial has. So x squared plus 5 equals 0. If I subtract 5 from both sides, I get x squared equals -5. And then to get x by itself, I have to take the square root of both sides. So I get x equals, all right, well this is where people go, we can't take the square root of a negative. Well, actually, what is the square root of -1? It's I. It's an imaginary number. It's a complex number. All right? So we can break the square root of -5 down into the square root of -1 times the square root of 5, which gives me the square root of 5 times I. And of course we need to put the plus and minus because we took the square root. All right, so the way I kind of think of it is it's like you're taking this little line right here and you're taking it out and you're putting it in the front and making an I out of it, okay? You could think about it that way, all right? So these are imaginary roots. Imaginary roots do not cross the x-axis. Only real ones do. So this polynomial still has two roots, but one's a positive imaginary number and one is a negative imaginary number. And most of the time, polynomials have a combination of both. All right, so this leads us into something called the complex conjugate theorem. And I'm hoping that this rings a bell a little bit and you're remembering something from a previous lesson called the irrational conjugate theorem. And that's one I was talking about with it reminds me of the conjoined twins, remember that? You can't have one without the other. And that was with irrational numbers where if one of your roots is in this form, then one has to be in this form and vice versa. Well, this one is very similar. If you have a root or a solution that's a complex number, which means it's got an I in it, and it's in this form, then it also has to have one that is in this form. Okay, so if you have one that's 4i is one of your roots, then -4i is also going to be one of your roots. If 1 plus 3i is one of your roots, then 1 minus 3i is also going to be one of your roots. It's just how it is, okay? All right. In other words, you need a pair of Mike Wazowskis. Two eyes. You need a pair of eyeballs. And I don't care if you think it's stupid. If it helps you remember, then there it is. Ha 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 ha. Get it? Okay. All right. Let's stop here and let's talk about solving polynomial equations in the next video.